Hey guys, welcome to week 8, the final week of online learning, and we're doing lesson 1 and we are looking at tree diagrams today. So by the end of this you need to be able to understand how tree diagrams are used and to be able to construct a tree diagram to show all possible outcomes of an experiment. So we're just going to do a quick about tree diagrams. So tree diagrams are used to list the sample space for experiments with 2 or more steps. So let's say if you were to toss a coin. So if you toss a coin, you've got a chance of a heads or a tails. But then if you toss it again, you got a heads or a tails. Or if you got a tails first. And this just shows you, and it keep going on and on. So I could keep going heads, tails, and keep going through. Like that, and you just keep going, and so they can get really big. So the outcomes for each stage of the experiment are listed vertically, so they're listed down here. So using this guy here, I had heads first. So if you look here, heads. The other choice I had was heads, tails, heads, tails, sorry. So you go heads, tails. Then you could go heads, tails, tails. And so they're usually just listed all down the side in order. So if you were to keep listing this, it would continue to look a bit like this. Alright, so they're listed vertically, and then each stage they're connected through these branches. So if drawn nice and neat, it actually looks a little bit easier to read than what I've done here. So for example, we are going to come across 2 things. So let's say we toss a coin 3 times. Okay, so a bit like what I've just done before. So you go, I'm going to use a different colour here. Go heads and tails. So there's your 2 when you toss your coin the first time. Alright, then you could go again. So once you go again. So if you look at that, we've got 3 different things. So here's your first time, your second time, and your third time. And these are all our possible outcomes that come from it. And we call this one with replacement because when tossing a coin, you can't just get rid of the tails the first time it comes up. It's just going to keep happening. So with replacement tends to be things like you'll have dice, coins, or if you're pulling cards out of a hat and put it back in after you get it. Then we've got ones that are without replacement. So let's say we had cards with A, B, C on it, and we put them in a hat. And if we pull out an A first, we don't put it back in, alright? And then we go to pull out our second letter, and there's only a B and a C left. And it's a similar thing for the rest of them. Right, so if you pulled the B out first, only the A and the C's left. If you pulled out the C, you'd only have the A and the B left when you go to do your second draw. And they call that without replacement because we're not putting it back in to be possibly drawn out again. Okay, so just keep a watch out for that important without or with replacement in any questions you're doing. Okay, so let's do an example. So we'll do 2 examples, one with replacement and one without. So we've got an experiment involves tossing 2 coins once each. All right, complete a tree diagram to show all the possible outcomes. All right, so you once again have your heads and your tails. And then heads and tails. All right, and then if we list our outcomes, you have heads, tails, heads, and tails. So there's 4 outcomes possible in total. And that's important for later. So what is the total number of outcomes? 4. Alright, now we're on to our probability parts. So find the probability of getting 2 tails. So the probability of getting 2 tails, there's only one of our 4 outcomes. So it's going to be 1 on top, and because there's 4 outcomes, a 4 down the bottom. Alright, find the probability of getting 1 tail. If you look at our outcomes, we've got 2 outcomes that have 1 tail. So that becomes 2 over 4 which can be simplified to a half. Alright, then our last one is at least one head. So you could have, that's got one head in it minimum, one head. So you got 3 out of 4. So when it says at least, it means it can have one or more. Okay, so that's what that means when you get the at least. And then that's actually it for the question. So we go on to our next example, and we've got 2 people are selected at random without replacement from a group of 3. We've got Annabelle, Brody, and Chris. And instead of writing their names out, we're going to go A, B, and C. So list all the outcomes. So remember that important without replacement is written there. All right, so once they're selected once, they can't be selected again. Okay, so what if we select Annabelle first, then that leaves us with only a choice between Brody and Chris, and we just keep that going. Okay, so we've got Brody and Chris left, Annabelle and Chris, and then Brody and Annabelle, and I put that in the wrong order. Right, list our outcomes: A, B, A, C, B, A, B, C, C, B, and C, A. Okay, so we have 6 outcomes. Okay, so then we've got find the probability that this selection will contain Annabelle and Brody. So if we go and look and go, how many have we got Annabelle and Brody in? Our first outcome, and there. So we've got 2 with Annabelle and Brody. So we're going to have 2 over 6. And this can be simplified down to 1/3 by halving both numbers. Okay, our next one is find the probability that a selection will contain Chris. So we look for all our selections with Chris. We've got 1 there, 2, and there. So we've got 4 all up with Chris in it. So that's 4 out of 6. All right, and that can be simplified to 2 out of 3. All right, now the last one says a probability of getting Chris or Brody. And this is a bit of a trick question in which the probability of getting Chris or Brody, you've got a 100% chance of it. Because look here, we've got Brody, we've got Chris, Brody, Brody and Chris, Chris and Brody, and then Chris. So if you look at that, it's actually 6 out of 6, which is just 1, which is also 100%. Okay, and then that is it.